Okay, in this video, let us look at an interesting example or an application of the prime factorization to find the square root of a given number. Now, let me flip the problem. Let us say we are given a number m and we are asked find out whether it is a perfect square number or not, and how would you do that? Now, we already learned about a property of the square numbers, and that by inspection could let you know whether a number is a square or not. So the step one would be to inspect the unit or the digit. You would just check the digit in units place. The digit in units place. So what would you check is the digit in units place either a 0, 1, a 4, 5, 6 or 9. Now this is the first check, and at times even this check is enough to tell you whether a number is a square or not. So for example, let us say that you are given a number, let us say 2352. In this, you can straight away tell that it is not a square number, primarily because of the fact that in squares, a square can never have a number ending in 2. That is, it cannot have a 2 in the units digit. So the first check is if you check whether is this, if it is no, which means the number, the digit in the units place is not 0, 1, 4, 5, 6 or 9, you can straight away conclude that it is not a square number, not a square number. So this is like the first level of check that you should be doing. Now the second one, what if the number actually has one of these? So let's say that you have 2355. It has it. So you can see that it has 5 over here. But do you think that just looking at this digit is sufficient for us to figure out whether this number is actually a perfect square or not? Well, it isn't sufficient, and you will soon figure out why. So if we find out that the digit in the units place is one of these 0, 1, 4, 5, 6 or 9, then it could be a square number or it could not be. So this would be your step 1, and the step 2 we will do further checks to figure out or to find out if I could represent this number m into a product of another number multiplied with itself. If I could represent this m as n cross n, then I could say that yes, it is a perfect square number. And this is where we can use the prime factorization method. So let us say that we are given a number, for example 2, 3. Okay, let me take a simple one. Let's say that we are given the number 85. Can you say whether it's a square number or not? Well, you know that there are only a few numbers from few perfect squares from 1 to 100, and you can tell it. But however, in order to understand the method of prime factorization, how we use it to figure out whether it's a square number or not, all we do is we do a prime factorization for this number 85. So you start with 2. Can you do anything with 2 for 85? So can you divide 85 by 2? No. So we take the next prime number, that is 3. So can we do that by 3? So 3, it looks like 3 also we cannot do, because 3 times 2 is 6, then it gives us 25. So let's look at 5. Okay, so 5 times what gives us this? So 5 times 1 is 5, and then you have 3, so 5 times 7 is 35. And then 17, as you can see, is actually a prime number, so 17 times 1. So the prime factors that you got for this is 5 times 17. So now you remember the prime factorization, all the numbers that occur in pairs, you need to have numbers in pairs. So essentially you would have something like 5 times 5 times 17 times 17. If you had something of this sort, and then we could just find out whether 5 and 17 are square, but this is not the case over here, and therefore we can conclude that 85 is not a square number or a perfect square number. Now we solve this problem, or we use this method of factorization for a very small problem. Now let's try to actually apply it to bigger numbers. For example, we are asked, is 2352 a perfect square? Okay, is 2352 a perfect square? If it is not, find the smallest multiple, or find out the smallest number that will convert 2352 in a perfect square. Now we already discussed about this, because it has a 2 in the units place. 2352, it has this digit 2 in the units place, therefore straight away you can say that this is not a perfect square. However, to be able to find the smallest multiple, the smallest number that can convert 2352 in a perfect square, we have to do the prime factorization. And so let's find out the prime factors for this number 2352 by the division method. So we say, we start with 2. 2 times 1 is 2. 2 times 1 again gives me 2. 2 times 7 is 14, and 2 times 6 is 12. So we could divide, we could again further divide 1176 by 2. So we have 2 times 5 is 10, 2 times 8 is 16, and 2 times, so we get 588. Again we can still further divide this by 2. So 2 times 2 is 4, but 2 times 9 is 18, and 2 times 4 is 8. We can still divide this further by 2. So 2 times 1 is 2, 2 times 4 is 8, and 2 times 7 is 14. Now let's see if we can divide this by 3. So we have 3 times 4 is 12, and 3 times 9 is 27, and what we have is 7 times 7 is 49. The next 7, 1. So the prime factors for this 2352 is 2 times 2 times multiplied by 2 multiplied by 3 by 7 by 7. Now all we do is we look at the pairs. So we have this pair of 2, we have another pair of 2. 3 does not have a pair, 7 is a pair. Okay, so now we have the answer over here straight away. If I were to convert this, I want to convert this into a square number, which number does not have a pair, and that is 3. So if we were to multiply 2352 by 3, okay, that would give us a square number. So 2352 by 3 actually gives us 7056, which in turn, the square root of 7056 you can easily calculate from this pairs over here. So we would have the square root of 7056 as 2 times 2 times 3 times 7. Okay, so that one, if you multiply this further, that is, we simplify it, and the number that we get is, so 3 times 7 is 21 multiplied by 4, which gives you 84. So the square root of 7056 is 84. So this kind of gives an interesting application of how we use the prime factorization to figure out whether a number is a perfect square or not, and also using that to find out what is the smallest number which we could multiply to that number to convert it into a perfect square.